Today we're going to be taking a look at what happens with static electricity. By the end of the day, you should be able to ask questions to determine the cause and effect relationships between electric interactions between two objects not in contact with each other. In other words, if I ask about the charges of two objects, I will be able to determine if they are going to attract each other or repel each other, even when they are not directly touching. So what is static electricity? Why do we sometimes get a shock when we touch other people or things? Like, have you ever walked across the carpet in some socks and then you grabbed door handle and you felt a little shock? Or maybe you've played with your brothers and sisters and you've built up a nice shock with your socks and then gone over and touched them just to give them a shock. Well, we're going to talk about kind of why that happens. Our big science vocabulary for the day is static electricity. Static electricity is an electrical charge that accumulates, that means gathers, on an object when it's rubbed against another object. So something interesting about static electricity is that we can pass it on. That's how you can pass it on to other people, or you pass it to the door. Things gather on you, but then we can transfer that to other places. But why does that happen? Well, to figure that out, we're going to have to go down to the really little level of the atoms. So what do we mean by charge? Everything we see, chairs, our desks, our feet, our bodies, our food, everything we see is made up of tiny little particles called atoms. Each atom has three parts, and they can have more than one of each of these things, but these are the main parts. They have protons, think P+. They have a positive charge. There are neutrons, they're neutral, they don't really have positive or negative. And there's also electrons that have a negative charge. So why does the charge matter? Well, have you ever heard the expression opposites attract? Well, it's like that with charges. So things that are positive and things that are negative want to come together. They want to attract to each other or come to each other, attach to each other. And things that are negative kind of push away from each other. So sometimes the electrons, those are the negative charge, they move between atoms. They can get shared or transfer between the two. This will make one atom negative and the other positive. Atoms with the same charge repel each other or push away from each other. So even if they're positives, if there's two positives together, they don't want to come together. It's like they don't like each other. And then the negatives, they also repel. But if you have a positive and a negative, they want to attract to each other. They want to come together. We see this in magnets. So that's kind of an easy way to demonstrate that. So we're going to go ahead and take a look at what happens with them. So let's take a look at what happens when we try to put two magnets together. What will happen when I try to put two magnets that are the same together? And what will happen when I try to put two magnets that are different together? So we're going to look at some magnets as a demonstration of what happens with atoms. I have two magnets that are the same. They look the same, but they also have the same polarity or the same charge. And then I have a third magnet that's a little bit different. Since these two have the same charge, what do you think is going to happen when I try to put them together? Do you think that they're going to attract or repel each other? What do you think?
I think they're going to repel each other.
Let's see. You're right, because it doesn't matter how hard I push, they don't want to line up. They keep pushing away from each other. Now let's see what happens when I use two different magnets. Do you think they're going to attract or repel?
Attract.
Let's see. You're right, because these two are different charges, so they want to come together. So when parts of our body, like our hair, become full of the same charge, they repel each other, just like the magnets we were just talking about. So when we rub a balloon on our head, the balloon takes the negative charges from our hair, and then our hair becomes all positively charged. Since each strand is positive, they try and push away from each other. So our hair gets all crazy, like these pictures. So in the first picture, we have someone It's not quite as crazy, and she's got her arm up. It's kind of hard to see, but maybe she's holding a balloon up there. And what do you think happened to this girl? She doesn't look very happy. Maybe she went down a slide and got a shock. Has that ever happened to you? On some of our playgrounds, I know with our plastic slides, we get our hair will kind of go crazy when we come down them, or we'll get a shock. And that's the same thing. It's the same idea. We're getting the electrons are passing between each other, between the objects. So sometimes our bodies hold on to the charge until we touch a conductor like a doorknob, and you can see the little like lightning. You don't really necessarily see it. Sometimes you do, but a lot of times you don't. You just feel it. And sometimes we actually pass it on to another person, right? We shock them. So now we're going to do our own experiment. You guys are going to check the polarity of a couple different things. Well, first I'm going to demonstrate the charge of a balloon and tissue paper. And we're going to look and see what happens when I take a negatively charged balloon and touch it to positively charged tissue paper. Then once I show you that, we're going to try the same experiment with the balloon, but we're going to try it with something else. We're going to try with salt and pepper. So let's take a look at what happens with the balloon and tissue paper first. All right, now we're going to look at another example of static electricity. So I have a balloon, and this balloon is negatively charged. I also have a piece of tissue paper, and it's positively charged. And I know because I rubbed it on my head, and my head took the positive electrons, and now the balloon is negatively charged. What do you think will happen if I get the balloon close to the tissue paper balloon?
The balloon will make it go like up.
You think it'll attract it?
Yeah.
Let's see. You're right. It's like magic. So the tissue paper is attracted to the balloon because they have opposite charges. Okay, so we saw that the balloon is negatively charged, and it affected the positively charged tissue paper by attracting it. So now we're going to check and see if we can figure out if salt and pepper are negatively charged or positively charged, and if the balloon has any effect on them. And is it going to be the same or different? Because salt and pepper, they kind of look the same except for the color, right? We know they don't taste the same, but they kind of look the same. But we're going to see if the salt is positive or negative and the pepper is positive or negative, and we're going to be able to tell that by getting the balloon close to it and seeing how it reacts. So the purpose of our experiment is to compare the effect of charges on the movement of objects. So is our positively or negatively charged balloon going to affect the other material, our salt and pepper, when we get close to it? So we're going to see which one is going to attract to the balloon. Are they both? Or neither? Is one or the other? And what we're going to need are balloons, plates, salt, and pepper. So I'm going to pass out a sheet to you for you to record your observations. And then I want you to glue it into your journal, and we're going to answer some questions. So this is what I want it to look like. So here's an example. On this first page, this is what I'm going to pass out to you, and you're going to fill it out. It says Experiment 1, Static Electricity. The purpose is to compare the effect of charges on the movement of objects. We just talked about that. So which material will attract to the balloon that is rubbed on your head, the salt or the pepper? So first you're going to use our scientific method and talk about your hypothesis. What do you think will happen? Here are materials. Here's our procedure. We're going to rub the balloon on our head, hold the balloon close to a pile of salt and pepper, and record what the salt and pepper does in the data chart. Here's our data chart down here. We're going to do this 3 times. You're going to do it in pairs so you can take turns, or maybe one of you wants to do all of them and the other person wants to record the data. Then we're going to talk about what are our results. So you can choose to either draw a picture of what you saw or write about it. And then what's your conclusion? Is salt and pepper positively charged, negatively charged, or whatever it is that you find? Then I want you to cut this out, cut it down to size, glue it into your scientific journal, and then we're going to think about, just privately, individually, when you're done, a few things that you learned today. When you're done, we're going to turn this in, and I'm going to look at it just to see what you had to say and what you thought about. So you're going to draw a picture of an example of static electricity. You can draw a crazy hair or another one, anything that you want. And I want you to think about this. If lightning is an example of static electricity, what do I think is happening when it strikes based on what I learned? So this is the I and this is you. What did you learn? And I want you to write at least 3 sentences.